Okay, yellow light from a sodium lamp of wavelength 590 nanometers, right? So our wavelength is 590 times 10 to the minus ninth meters. Is incident at normal incidence on a double, that means it's just at right angles to it. Double slit. The resulting interference pattern is shown on the screen. So this is these maxima here. These are the famous, this separation here on the screen, that S is lambda big D over D, right? Where D is the slit separation, D is the distance to the screen, okay, et cetera, right? Or more careful, for more careful work, right? N lambda is D sine theta, if we're going to do that, right? So that is the due to the separation of the slits, right? But then there's also this sort of overlying. This is the single slit diffraction pattern, okay? And we're to believe that theta is lambda over b, where b is the width of the slit or the size of the aperture, okay? Really, this should be sine theta is equal to that, okay? But, you know, what the heck, let's just go with this. Okay, explain why zero intensity is observed at position A, okay? This has to do with the single slit diffraction pattern, so due to one of these slits. So if we looked at the slits, right, it is the width of that slit, that's our B there, okay? And so what's happening there, if you recall with a single slit, if I can draw a picture of it, is that there's light going through the middle, and that is going to be a half a wavelength difference from the, so basically we've got a spot here that's, right, and if we draw the little triangle here, this becomes a wavelength here, and then this becomes our B is this distance here, right? Okay, and so the difference between the center and the edges is a half a wavelength. In the center, it'd be a half wavelength, right? This is 0, this is 1 wavelength, and so the center cancels out the edges, okay, and you get this dark spot, and that's why it happens, okay? So I don't know, talk about that, right? Or you could, I think you could just kind of maybe BS your way through it, see how that works. I can't remember the mark scheme, but you want to talk about the single slit diffraction pattern, how that's a minimum of the after the first central maximum, okay? The distance from the center of the pattern to A is 4.1. The distance from the screens is 7 meters. Calculate the width of each slit. Okay, so really what you can do, okay, is you can say, look, that angle, according to IB, right, is lambda over B, and you're trying to solve for B. This is the formula in the data packet, right? Okay, that angle also is just that distance divided by the distance to the screen, okay? So you can just set these guys equal, basically, okay? So lambda over b, b is what you're solving for, right? It's also going to be that distance divided by the distance to the screen, okay? Lambda is 590 nanometers, right? And then you can solve for b. I got something that was satisfyingly even, okay? Close to 1/10 of a millimeter, okay? All right.